Okay, so 3, 3, multiply and divide rational expressions. Starting off with just some simple numbers and talking about how do I simplify, right? So I know that you can hopefully simplify 12 over 16 on your own. I'm going to break this down into tiny little pieces just because I'm trying to demonstrate what we're going to do next. So if I were to take and I were to do the prime factorization of 12, right? If I were to take and do like a factor tree for 12, I would find that the prime factors are 2 times 2 times 3. If I were to do the prime factorization for 16, I would find 2 times 2 times 2 times 2. Now, we get used to doing this in our head because we get really good at multiplication and division. But essentially, when I'm simplifying, when I'm reducing 12 over 16, I am canceling out one of those factors. So I cancel out a factor. I can cancel out another factor. Because 12 and 16 are both divisible by 2 times 2, which is 4. Right? And then when I simplify this, I am left with 3 divided by 2 times 2, which is 4. So that's the simplified fraction. Now, in our heads, I know that you can divide by 4 and get 3 over 4. But just trying to go through the process to help us inform us while we get into rational expressions. All right. So then B, when I multiply, again, I'm going to write this out as a product of its prime factors. 4 is 2 times 2. 3 is prime. When I take 27 and do the prime factorization, I get 3 times 3 times 3. When I break it down into its factors, 3 times 3 times 3. Whoops, I wrote the wrong number there. 8 breaks down into 2 times 2 times 2. When I'm simplifying a fraction, I can simplify up and down. When I'm simplifying a multiplication problem, I can simplify up and down. I can also simplify diagonally. Because essentially everything in the numerator is all multiplied together. The 2 times 2 times 3 times 2 times 3. And everything in the denominator is multiplied together. 3 times 2 times 2 times 2. So I can cross cancel this way. 2 cancels with 2. 2 cancels with 2. And a 3 cancels with 3. Which leaves me with 3 times 3 on top. So 9, and then a 2 on the bottom. Dividing by a fraction. We tend to not do this. We like to steer away from dividing by a fraction. What we do instead is multiply by the reciprocal. So instead of 10 halves divided by 20 over 7, I'm going to multiply by 7 over 20. So I change the division to multiplication and I flip the right-hand side fraction only. I can break 10 down into 2 times 5. 2 is prime. 7 is prime. And I can break 20 into 2 times 2 times 5. Now that I have multiplication, I can simplify up and down or diagonally. So one pair of 2's will cancel. The 5s will cancel, and that's going to leave me with a 7 on top and 2 times 2, which is 4 on the denominator. A rational number is the ratio of two integers. So I have an integer divided by an integer. An integer is a whole number or its opposite, including 0. So this is a rational number. Anything that you can write as a fraction is a rational number. Rational expressions are what we're talking about today. A rational expression is the ratio of two polynomials. The domain of a rational expression is all real numbers except those which make the denominator equal to 0. And we call these restrictions. The work we do to simplify rational expressions is going to look very similar to the work that we did when finding points of discontinuity for rational functions. They're closely linked. Cool. So example 1, simplify. So just like we did with rational numbers, we did 1 simplify, 1 multiply, 1 divide. We're going to do a couple for the rational expressions, a couple simplifies, a couple multiplies, a couple divides. Again, a day chocked full of factoring. I've got some steps listed there. You can write them down now or later if you find them useful. Basically, we're going to factor, then find the restrictions, and then cancel, just like we did in 3-2. So step 1, I factor. Notice that this is an expression. It's not a function. It's not an equation. On top, x cubed minus 5x squared minus 24x. Always look for GCF first. Yes, there's something I can take out of all of those terms. I can factor out an x. When I do that, I'm left with x squared minus 5x minus 24. Keep factoring. So I have an x in front. If you have to go through the process of doing your product sum and making and rewriting your terms and using the box, okay, go for it. When the coefficient of x squared is 1, this is pretty easy for me to do in my head. Because I know the only way I can get x squared is to have x and x right here. And then I'm just going to play with the factors here to figure out what multiplies to 24 and adds to negative 5. So I know x times x is x squared. I know negative 8 times 3 is negative 24. And in my head, I check the outside inside. So 4 times 3 is 3x. Negative 8 times 3 is negative 8x. When I add that together, I get negative 5x. That's how I'm checking. All right, so I factor the top. I'm going to factor the bottom. I have a GCF again, so I can take an x out of all of those terms. Again, I'm just factoring what's inside the parentheses now. The only way to get x squared is x times x. Numbers that multiply to 72. Yeah, there's kind of a lot of them. The ones that are going to work here are 8 and 9. I have to get a sum of 1x. It's going to give me a positive 8 and a negative 9. I don't expect you to be as fast as me, but I'm hoping through the course of this unit that you can start cutting down on your steps of factoring and start being able to do some of the more simpler ones in your head. Just save yourself on work. If you can't, if you have to do all the work, that's fine. All right. So step 1, I factor. Step 2, I find the restrictions. Before I cancel, I'm going to find restrictions. So I'm going to take each factor in the denominator only and set it equal to 0, just like I did when I was finding points of discontinuity. Now, I guess I'll go slow on this first one. So I take each factor in the denominator only. I set them equal to 0. Solve for x. Oh, this just gets written a little differently. I know that this whole expression falls apart if I were to plug in 0, 8, or negative 9. If I plug in 0 or 8 or negative 9, one of these factors turns to 0, and I cannot divide by 0. It does not exist. It's undefined. So my restrictions on x are these 3 values. X cannot be negative 9, x cannot be 0, x cannot be 8. Then I'm going to go back to my expression and simplify. That was my initial target, right? Simplify and state the restrictions. So I simplify, cross out whatever factors I have on top as I have on bottom. Same thing I was doing up here, right? The x's will cancel, and the x minus 8s will cancel. In my answer, I'll be left with x plus 3 divided by x plus 9. You might be tempted to try to simplify that more. I've seen students cross out the x's. I've seen students try to simplify the 3 over 9. You can't. I can only cross things out if they're multiplied. This is an expression that's added. That has to stay. Cannot simplify that. I can only simplify factors that are multiplied. I can't break that up. X plus 3 has to stay together. X plus 9 has to stay together. So here is my simplified expression and my restrictions. I'm going to pause and let you try B. So step 1, factor. Step 2, find the restrictions. And then cancel and rewrite. If you want to check your factoring, before finishing the problem because you're apprehensive. It's factored for you on the screen. Now, when I find the restrictions here, remember that I'm only looking for restrictions on x. The 2 is not going to cause any restrictions. It is a factor, but it's not a factor that has any effect really on the restrictions on x. So I will take x plus 5 and x minus 2, but the 2 is not going to, a little bit of a lag. Let me get closer to the device. Interesting. All right. So I would have x plus 5 is equal to 0 and x minus 2 is equal to 0. This seems to have, there we go. Yeah, it caught up. Okay. So I get x is equal to negative 5 and x is equal to positive 2. But those are the restrictions. So even though I'm writing that's what they're equal to, it's actually what they're not equal to. X cannot be negative 5 and cannot be 2. Restrictions only occur in the denominator. I can have a 0 on top. That's fine. It's not a problem. If I were to plug in negative 2 to the x plus 2 on the numerator, I would have 0 divided by some number, and that's fine. That's just 0. It exists. Then we look for factors that I can cancel. So I need to cancel the entire factor, like x minus 2 and x minus 2. Now, there's 2 ways to go when I'm rewriting the simplified answer. I'm going to have you just leave it in factored form. There are other ways of thinking that you should multiply back out what you have. We're just going to stop here and not multiply back out. Just don't think it's a necessary step. All right, so my simplified answer is x plus 2 divided by 2 times x plus 5. If given a multiple choice test, hopefully you could recognize if this was multiplied out, right? 2 times x is 2x, 2 times 5 is 10. We're just going to leave it like that. All right, example 2. Multiply. State the restrictions on the variable. This time I have a rational expression times a polynomial. I'm going to rewrite all of this in factored form. Now, when I spend a little time factoring x to the fourth minus 16, it can actually be factored 2 times. So it is a difference of squares. So when I'm looking at what factors is x to the fourth, well, x squared times x squared gives me x to the fourth. And 16 is also a perfect square. X squared plus 4 cannot be further factored, but the x squared minus 4 can. It's another difference of squares. So x squared minus 4, we know just factors x plus 2 and x minus 2. All right. So here I've got x plus 2 divided by all those factors. So x squared plus 4x plus 2x minus 2 times when I factor x cubed plus 4x squared minus 12x, I can factor out an x and then factor the rest. And when I'm looking for numbers that multiply to 12, but add to 4, I'm going to go with 6 and 2 here. 6 has got to be positive, 2 has got to be negative. Now, when multiplying by a whole number, that's the same as I could just put this in the numerator of a fraction and put a 1 on the bottom. They're the same thing. I can just put that all over 1 if you feel more comfortable having a fraction on both sides. When looking at the denominator, I've got 3 factors, and we see a unique situation here, which is worth discussing. The obvious restrictions occur at 2 and negative 2. This other restriction isn't a real number, so it's not going to count. So when I subtract 4 from both sides, I get x squared is equal to negative 4. And when I take the square root of both, I get an imaginary number. That's not going to cause a restriction in the real number system. So it doesn't count. It's kind of an odd thing. So we're not going to mind that one. My restrictions then are going to happen at negative 2 and 2. I cancel what I can cancel. So I've got an x minus 2 and an x minus 2. I can cancel diagonally. I can also cancel up and down. So I have an x plus 2 and an x plus 2. Those can also cancel. Yay. This leaves me with an x times x plus 6 in the numerator and an x squared plus 4 in the denominator. We saw some different factoring in that problem and some different things happening with restriction. So take a moment to think about it and let me know if you come across with any like ahas or any questions or any points of confusion or concern. Anybody want to ask any questions on this problem? Okay, I'm going to start by setting you up for B, and then I'm going to let you finish it. There's just one thing in there that's a little different. We're already halfway through the notes, so it won't take us too long today. So for problem B, we've got x squared minus 16 divided by 9 minus x times x squared plus x minus 90 divided by x squared plus 14x plus 40. Make that a little higher so you can see it. And the part that I want to give you some direction on is this bottom part right here, which looks a little different. When I go through my process of factoring, 9 minus x can be rewritten as negative x plus 9. If I just write it in standard form, I just move the term with the highest degree to the front, keeping the signs. And then when I factor, we've talked about whenever there's a negative, you have to take that negative out. So I'm going to factor just the negative out, which is basically going to change the sign. So I factor out a negative, I'm left with a positive x, and I'm left with a negative 9. So when writing out all the factors, the denominator of the first fraction is going to look just like that. And I know the factoring can be tiring, but I'm going to leave you to do the rest of this problem. Give it a shot. I'll walk around if you need some help. Factor all the other trinomials. top, x squared minus 16 is just a difference of squares. So we studied this in the last chapter, where if I have a perfect square minus a perfect square, then that factors pretty simply. So if I have x squared minus 16, right, I can think about that as x squared minus 4 squared, which can be rewritten as x plus 4 and x minus 4. So that'll be my first numerator, and it doesn't matter if I do x plus 4 and x minus 4 and somebody else does x minus 4 and x plus 4, it's all the same. When I factor the numerator over here, the only two things that can multiply to x squared is x and x. So that has to be x right here. Then to multiply to 90 and add to 1. Then I have plus 10 minus 9. Things that multiply to 40 and add to 14. X plus 10 and x plus 4. I'm going to find all those restrictions. Now, frankly, guys, I don't feel the need to go through the process and set x minus 9 is equal to 0. Add 9 to both sides. X is 9. I can look at this and take the opposite and recognize that fairly quickly. If you feel comfortable with that, jump that step, okay? I know that when I set, just like I did up here, boop, 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 right? If I have x plus 2, I set equal to 0, I subtract 2 from both sides, I just end up with the opposite. So this is going to give me x equals 9. This is going to give me x equals negative 10. This is going to give me x equals negative 4. You can skip those steps. It's okay. Therefore, I know x cannot be negative 10, negative 4, or 9. If it's any of those values, then I would be dividing by 0, and I can't divide by 0 because it's undefined. And then we simplify. All right, what do we got? We got x plus 10s, those cancel. Boom. X minus 9s, those cancel. X plus 4, those cancel. Okay, that leaves me with an x minus 4 up top and a negative on the bottom. I can't just have a negative, so I'm going to turn it to negative 1. I am not leaving that like that. That looks way too funky. So I'm just going to change my signs. X divided by negative 1 is a negative x. Negative 4 divided by negative 1 is a positive 4. Boom, simplified. Now, an added note for dividing. When dividing, we have to find restrictions before and after taking the reciprocal. So it just adds a step. Remember that instead of dividing by the right-hand side, I'm going to multiply by the reciprocal. Everything else is the same. So first thing first, I'm going to factor, then find restrictions, multiply by the reciprocal, find the restrictions again, and then simplify. Step 1, to factor. Step 1, take out a GCF. 3x squared minus 18x. Let's see. I can take a 3 out of both of those and an x out of both of those. 3x squared divided by 3x. 3 divided by 3 is 1x squared. Take away an x, I'm left with an x. And then negative 18x divided by 3x gives me negative 6. We'll have an x minus 6 on the bottom also. All right. Just like we did before in example 2a, I'm going to turn this into a fraction by writing it over 1. Always check for the GCF first. X squared plus 9x. Yes, I could take an x out of both of those. And nothing else. So I focus on the denominator. The denominator creates some restrictions for me. I have that x cannot be 6. On the right-hand side, I just have a 1. There's no variable there. That doesn't create a restriction. So I factor, find restrictions. Now I'm going to multiply by the reciprocal. So remember when I do that, I change this to multiplication and I only take the reciprocal of the right-hand side fraction. Then I have multiplied by 1 divided by x times x plus 9. And now I need to account for new restrictions because I have a new denominator. So from here, I get that x cannot be 0 and cannot be negative 9. Now I simplify. So the x minus 6's can cancel. There's something else that'll cancel. The x's. So on top, I'm left with 3 times 1. That's just 3. And that cancels, and that cancels, and that leaves me with x plus 9 in the denominator. X plus 9 is an expression. I can't reduce by 3 unless every 3 goes into everything. So this, the 3 and the 9 cannot be reduced. That's it. It stays like that. Don't try to simplify more than seems natural. Have an example for you to try. I'm going to go ahead and do the factoring for you, okay? Try to ease the burden. Steps are the same. 1, factor. If you want to do that on your own because you need the practice, go for it. Otherwise, you can copy down my factoring. A lot of 4s and 1s and x's in this problem. Yikes. And I'm going to ask you to do the problem from here. Find the restrictions, multiply by the reciprocal, find the restrictions again, and simplify. Let's see if you can get all the little pieces. Now, when you move forward and you look for the restrictions, you should get that x cannot be equal to -1, -4, and 1. You'll see 1 show up twice, but I don't need to list it twice. And then before simplifying, we're going to multiply by the reciprocal. Check for any new restriction. So when I check the new denominator, x plus 4, oh, well, that's the same thing. I already have -4. Okay, good. And then x plus 1, well, I already have -1 in my list, so we're good. There's no new restrictions this time. Woo, let's cross out everything we can. Let's see. X minus 1, x minus 1. X plus 4, x plus 4. I think that's it. I'm just checking all my signs. Fearful I made a mistake. I think that's it. So I'll be left with x minus 4 times x minus 1 and x plus 1 times x plus 1. Now you could certainly multiply that out and get an equivalent answer, but you don't have to. Any questions that I can answer? That's it for 3-3. It's a lot of practice of other things that we've done and a lot of factoring. That brings us to the